Okay, we are now being recorded. First, I'd like to say welcome to everybody and get some thank yous out of the way. I want to say thank you to all of our developers and contributors to ROS-Industrial. Without you guys, this really wouldn't be possible. We appreciate all the work that you do. You know, ROS-Industrial is truly a worldwide community. We have contributors and developers across the globe. Thank you for the ROS-Industrial Consortia. They fund a bit of the work that we do, and they make things like this community meeting possible. Thanks to Southwest Research Institute. That's my employer, and a good number of ROS-Industrial developers are employed here as well. And they let us do, you know, this really cool work, so we really appreciate that. And thank you to everyone who's come to join us today. I know your time is valuable, and spending an hour or so in an online meeting it takes time away from your day, and I appreciate that. I hope the information we give you is going to be considered valuable to you. Just real quick at our agenda, I'm going to take the first 10 minutes or so to just give an introduction and let you guys know what's going on in the community, but I will try not to talk too much. And then we're going to hear several what we call mini talks, which are 15 minutes or so 12 minutes of talking and maybe 3 minutes of question and answers from various people within the community. I think we have a really good lineup today, a good mix of presentations, industry, academia, and I think the material that they're going to present is very interesting. So first we're going to hear from Lex Tinker-Sackett from 3M about an initiative to create a PackML state machine library. I'm not going to steal Lex's thunder, but I think it's a very worthwhile endeavor, and I'm very supportive of it. We're going to hear from Saito from TORK about industrial CI. CI stands for continuous integration. I'd say it's kind of a mini project that Isaac started, but it's really gotten traction, and I'm really excited about what he's been able to do, and he'll share details about that. And then Mitch Pryor from UT is going to talk about a planned code release of the work that they've been doing as part of the nuclear robotics group at UT. We've been working with Mitch for a very long time and seeing really cool videos of things that he's been able to do, and I'm excited about the release of some of the software that enable those videos. And then Dave Coleman is going to talk about multi-arm control in MoveIt. Dave works at the Correll lab at the University of Colorado in Boulder. Multi-arm control is definitely an interesting research area, but there are industrial robots out there that, whether you buy them as multiple arms or not, could really benefit from the work that Dave's doing. So I'm thinking that will be very interesting as well. And then just at the end of this meeting, we'll have some general question and answer and closing remarks. So I just want to give an overview of new developments in ROS-I. Just a quick shout out to people I think who are doing really good work, and the development that they're doing and the contribution that they're putting in is relevant to the broader community. So you can see all the latest developments on our blog certainly, but here are some highlights. Just recently, Levi Armstrong put out the Qt Creator plugin, which essentially creates an IDE for ROS. I invite you to go look at the blog post there, but if you're one of those hardcore VI Emacs developer guys, you probably have no interest in this, but if you're like myself and you just want code completion and you want your life to be, you know, easier to jump around in a fully featured IDE, I think this is really an incredible contribution because it enables that for ROS development, which is what we all want. A shout out, this is not a ROS-Industrial project. TrackIK is actually a library put out there by Track Labs, but TrackIK is an inverse kinematic solver for industrial manipulators. Just about everything we do depends on IK solutions. And I'm, you know, even though it didn't come out of ROS-Industrial, I'm very excited, so I wanted to put it on here and give Track Labs credit for doing a really awesome job. You know, if you ever find that you're doing path planning in MoveIt and getting weird results, don't blame MoveIt so much as you might blame your IK solver, and consider looking at the TrackIK solver. We have a package here at Southwest Research that we developed called Descartes, which is for semi-constrained Cartesian path planning for things like welding and painting, so very industrial applications. And thanks to Jonathan Meyer, it keeps getting faster with every pull request. And we're very excited about getting that in the hands of others. There are quite a few people out there on this call who are using Descartes. And we're really excited about where that's going. And then new robot support. So we're looking at Stably support, which is being developed by a company called Ocado. And if anybody's interested, we're actually looking for people to maybe beta test the Stably driver. We feel like we're very close to a release there. So we're excited about that, and we're certainly thankful to Ocado. And kind of, you know, up and coming are Mitsubishi and Epson drivers. Again, we're excited about having further support for more robot platforms. So, see, in upcoming developments, upcoming events, you can see our event summary page. There's lots of information there. There's the ROS-I developers meeting, which is July 12th, 2006. So every month we hold a developers meeting. These are for contributors or people who are interested in contributing. We talk about the technical details of implementation, and it's really exciting from a development standpoint. If you are interested in joining that, you need an invite, but feel free to email me for an invite if you just want to learn more and kind of see how we run our project internally. There's going to be a Asia Pacific workshop in July. We're really excited about this. We know there's kind of building interest in ROS and ROS-Industrial in Asia, and we're very interested to see who comes to that workshop. Please follow that link and get information if you think you might be interested in attending. Agile Robotics for Industrial Automation Competition. There will be a kickoff meeting at the CASE conference in August. This is a simulation competition put on by NIST, but it's really focused on making factories more agile or able to build many different things without having to retool or reprogram. It's an exciting project or exciting competition. It has some really cool sponsors, big companies who are interested in this. And then also ROSCON 2016 proposals are due 7/8. We're excited to see the so ROSCON is going to be held in South Korea, I believe. It's going to be in Asia this year. Maybe somebody on the list can tell me if I got that right. Proposals are actually due in July for speaker positions. So if you're interested in speaking at ROS-Con, you should submit a proposal, and you can follow the link there to submit a proposal. It's really cool. You can talk about whatever you've done in terms of ROS, not just ROS-Industrial. We love going every year, and we would encourage people to submit proposals. Okay, here's my one slide of what I think, what I would like to present. I really feel that ROS-Industrial is becoming a true community project. As I said, we have developers from around the world, and we have continued interest both from industry and academia. We want to leverage that as much as possible. And one way to do that is to grow our community of contributors. And really, this is not. This is really driven by need, because the ROS-Industrial software that's out there and that continues to be contributed, we really need more people to help with that. We're kind of outgrowing Southwest Research and some of the organizations that we partner with around the globe, and we really want to build this out to be a global community of not just a handful of companies, but a bunch of contributors. So what will we be doing? Well, in the near future, we're going to do a push to recruit contributors. You have to recruit contributors just like you do employees. There are people out there who may be interested, and we're going to go find them and see what role they might play within ROS-Industrial. You'll also see that we'll be updating documentation for contribution. So we have to document the process, and the goal is to make it easy for the newbie contributor, right? Somebody who's not familiar with ROS or ROS-Industrial, but make it very easy for them to contribute. We want to bring new people into this organization, and better documentation is certainly one way to do that. Project ideas. So we'll document some project ideas. Sometimes people contact us and they just want to know what they can do. We have to document some of the ideas, things that we know need to be done, but we don't have the resources to do them, and maybe the community or a contributor out there can help with that. And then also project roles. We're getting big enough that we actually need some structure. To this point, it's been a little bit ad hoc. People kind of rise to the level that they're comfortable, or do perform a role that they just see for themselves. And that's great, and I want to continue that, but I want to recognize those roles as well. At least so that externally, when people want to contribute or reach out to ROS-Industrial, there's some key people that they know they can or should talk to. And certainly key people than just beyond the handful of people there are today. So that's what you'll see in the kind of upcoming months, and I'm really excited about this. I think we have this opportunity to grow our community. And with that, I will shut up, and we will move on to the mini talks. So first up is Lex. I'm going to change presentations, and Lex, hopefully you'll unmute yourself.
I did just unmute myself. Can you hear me?
I can hear you great, and I will mute myself so I don't bother you, and you should be good to go.
All right. First, I'd like to thank Sean and Paul at the Southwest Research Institute for including me in this. This is a great opportunity for 3M because this open source thing, it seems like it's kind of a good idea. I work for a company that doesn't include a lot of open source capabilities. So some of you may remember the old cathedral and bazaar analogy, the classic seminal work on open source versus big old-fashioned software development, well, I work for a company that makes cathedrals. So this is a new thing for us, and it's a little bit of a challenge trying to get through the legal processes, and I'm sure I'm not alone in that, but it's well worth it, and we're trying to get through it. To that end, I'd like to tell everybody that I am an open source newbie. This will be my first contribution to an open source project, and so if you have any hints or tips, I will welcome them. And let's get started here. I'm going to talk today about PackML, which is something that I actually did start looking into in 2014 as a way to advance some of our technology platforms here for manufacturing. We're going to go through a few things, just a quick introduction, go through PackML, talk about the PLC concept in terms of industrial automation, the advantages we get with PackML industrial applications, and of course the hopeful ROS PackML implementation that I hope many of you are interested in helping me with. First off, we have 3M itself, which is a company of around 88,000 employees worldwide. We do have 250 manufacturing facilities around the world and over 60,000 products. Somebody did put out a little info blurb one time about how you're never more than 7 meters away from a 3M product, pretty much anywhere in the world that's not in the middle of the ocean. And that is pretty much true. We make most of our products, you're familiar with Post-it notes and Scotch tape and things like that, but that's really only a small percentage of our total product mix. Most of our products go into other people's products. So a lot of LCD displays and roofing granules for your shingles on your roof, all of those things have some 3M input. For our team, we've got a great sponsor, Shane Shutnick, who is our sort of project champion for being included in this ROS project. And, well, he's the money, right? So he's the guy that gets us the dollars and the time to do these things. I'm Lex, and I do a lot of talking. I kind of am a coordinator. I put things together. I'm actually excited about this because I work in a company of engineers, but I'm a computer science person, so actually we'll get to do some C++ again. I'm very excited about that. Most of the time we don't do a lot of computer science work here. Most of it is PLC-based controls and automation, and that's something that I'm going to hit on in a little bit. Brett Hemis is our primary ROS contributor at this time. He is working on some Descartes updates that we actually did get through our legal department. I'm not sure how many of you work for big companies, but if you do, you know how hard it is to get things through legal. So one of our biggest problems is going to be how do we contribute legally with our corporate bylaws. John knows. Good. I'm not alone. And then we have Tom Stray, who is our actual PackAmell implementing developer. He is the guy who has done most of our actual implementation on PLCs. So what is PackAmell? It is an official standard. It's an ISA standard, and I have it written down there, and I think Sean, we're going to send these out as notes or make them available, right, so that people can get the links and stuff. I'll just assume that's a yes. What it is a guideline. It is not an actual. Thanks, Paul. Yes, we're going to send them out. It's a guideline for how to program a PLC in a way that makes it modular, in a way that makes it a standard, so that you can have more than one system talk to each other or have a body of knowledge about the way this control system is operating from a controls program standpoint so that it's easier to maintain. So just in general, kind of good programming guidelines to make things better for developers and maintainers of this code. That was one of the hooks. The big hook for me was something different. It allows multiple vendors to program to an industry standard. Now that's key. So in an industry like mine, where we have many machines that go into one process, having options for the ability to switch out vendors is usually very low. We either have to get one giant monolithic line developed by a vendor who usually has a lot of proprietary technology in it, or we can ad hoc mix a bunch of independent vendors, and then we have a lot of integration work that needs to be done. So driving to this PackAmell standard allows us to make a modular implementation that's standard and global, and we can force our vendors to comply to it. Now, the one problem I have found with this standard is that vendors don't want to comply to it if they don't already do it. So the initial implementation is challenging, but once we do get them over the hump and say, you must do this per our specification, the equipment comes out with it. We usually have a few modifications and changes, and then it's ready to go. But each vendor then can focus on what they're good at. We have several things that might need a certain technology. A vendor may be really good at web handling. Well, web handling is not something that injection molding people are good at. So if we need an injection molder and a web handler, we don't want one company to handle both. So this allows us to split the work up, give the vendors what they're good at, and make it work. In that way, it reminds me a lot of ROS, which is sort of what kind of sparked my interest in this whole thing. Here's a state diagram. It's the only picture, so enjoy it. The rest is all words. So the state diagram is kind of the heart of the PackAmell system. You can see that there are many states, and these. Okay, here's a tricky point. These all have to be implemented. They may be skipped, but some people look at them and say, well, why would I need a suspended and a hold? There's reasons. There's reasons for it that you might want to go through these states for a certain type of operation and have one thing that holds an operation and another thing that suspends it. Maybe an operator interaction suspends it, but a machine interaction holds it. Then you can have different logic going through while the machine was in execute mode, and it changes out and goes back into execute mode. These states are very carefully thought out over the last, I think it's 13 years or so for PackAmell development, and they all are useful and necessary for someone. They may not be useful for you, which is fine. You can have a state that literally just passes along to the next state, but they have to be there so that you can have the full state model represented. About 5 years ago, one of the groups in 3M looked at this and said, we don't need all that. They implemented a system that only used 5 of the states, and now, this last year, they had to rewrite everything to go ahead and use all the states. So getting a model together that uses all the states and allows for all of them so that we have good communication between the industrial platforms and the PC-based platforms or robotic controls platforms is really important. By the way, Gavin, ISA 95 rocks too, so that's awesome. Exciting just to be around people like you guys who have worked on this stuff. It's pretty rare in 3M. Controls and automation are important, but they're as with anything that has tightly controlled intellectual property around it, we don't share a lot. So this gives us a way to share on the things that don't matter, like how do we go from one state to the next and not tell people what each state does. So it's a very important tool. So this is one of the problems I had with PackAmell, is that it's not for packaging only. Discrete automation is a great tool for any kind of discrete automation, and it's a fantastic guideline. It was developed for the packaging industry primarily, and that's why it's called PackAmell, and it really can do more than just packaging. So don't be confused by the name PackAmell. And as I was down in San Antonio with the training on the ROS-Industrial stuff, I had the same thought about ROS. It's capable of so much more than robots. So, one of the drawbacks to PackAmell might be that controls people see pack and they think, well, we're not using that for an extruder line because it's packaging. Well, that's not necessarily the case. You can use it for anything. Just like some of the tools in the ROS implementation can be used for many communication tasks among various systems. So much more than it might seem at first. And again, just like with ROS, it's best practices. So there's a lot of good design pattern implementation in ROS, and the same thing for the state models in PLCs. I'm just going to, I know you can't answer the question directly, but my primary question for everybody is how many of you are familiar with PLCs? Sometimes we, here in industry, we assume everybody understands PLCs and ladder logic and knows everything about what we're talking about, but I've found that people who tend to be robot automation specialists don't necessarily like to deal with those messy little PLCs that don't do much. The key thing about PLCs is that they're everywhere. They're like rabbits in a field. Yeah, so we have some people that are PLC people. That's awesome. They're everywhere in industry. So talking to them is really, really important if you want to integrate your robots with industrial systems. In fact, when we try to include certain technologies like lasers in our systems here at 3M, we have some difficulty because laser control systems are almost always PC-based. So we don't like to share PC-based information with PLCs. We don't have the right tools for it. It's not in place. We have the same kind of issues with some of the control architectures for certain robot implementations. So being familiar with it and figuring out good ways to talk between the PLCs and the PC-based control systems is kind of key. What's neat about this whole PackAmell system is that the OMAC group, the Organization for Machine Automation and Control, they create kind of a resource guide for PackAmell that gives actual examples. The best one that we found is the Procter & Gamble example, and it is actually the PackAmell implementation guide from the OMAC website. You can download it, but you have to register for it, but it's totally worth it, so do it. It gives you the state diagram and a bunch of other things and good documentation. But this Rockwell AB example from Procter & Gamble it's a full template implementation so that somebody who's good with PLCs can just plop that into their Rockwell implementation and test it out, mess with it. Fantastic tool to be able to use. So even though you may not have access to it, if you do or you have people that are interested, I highly, highly recommend this PackAmell standard as a way to make your PLCs much more logical and easier to maintain. And the interesting thing that I found is that for industrial PLCs, this is really close. The whole ISA 88 concept is really close to open source for PLCs. It's not like you can run a AB Allen Bradley PLC code on a Siemens PLC, but you can pretty quickly translate the template and make it work. So it's really quite nice. So like with anything, having good standard interfaces is an advantage for PackAmell. The interfaces are primarily tags with a standard naming structure, but these loosely coupled interfaces that you have between various equipment modules that are set up with PackAmell, it could be a robot, could be a web line, could be an extruder. They can be vendor agnostic as long as they adhere to the interface standard. And then the standard state machine is really nice because it allows you to have no surprises, which is very important when you're programming controls and automation. It also has multiple modes. So the state machine that I showed you earlier, you can have layers and layers of those for various modes, where different programming models for setting up a line are in place with different operations. If you have a setup mode versus a maintenance mode, which might offer some, interlock defeating or some other types of things that you might want to use for testing, versus an execute or a run mode that would just be a full production automation mode. There's also the ability to set up something for a local mode where it's not connected to anything else so that it can run on its own. All of these things are capable with this PackAmell standard. And then we use OPC. I haven't heard of a lot of people talking about OPC. I think someone at the Fraunhofer Institute is working on the OPC UA type of tool for ROS. It's kind of key ingredient, and I would be helping with that if necessary because it's really important. OPC is really just a old-fashioned way to have a Windows computer talk to a PLC through a network communication. And then if you want to use it with a Linux computer or something else that doesn't require DCOM, then you can use the OPC UA, which is the new version. It's much better, but it still isn't widely implemented in industry here in the U.S. Industry uses PLCs. They're everywhere. Like I said, they're like rabbits. PCs are discouraged, and here at 3M, I know we have a lot of trouble because of virus concerns, operators surfing the web. I've gone into web lines in class 10,000 clean rooms where you're making stuff that kind of critical stuff for various components in a machine or a display, and there's operators surfing the web because they have the ability to do that on one of the pieces of equipment that was PC based. So that's bad. PLCs don't allow web surfing. They make things move. Their electrical engineers love them because they're ladder logic. Technicians can maintain them. They're going to be everywhere. And anywhere where you have a ROS-Industrial application, you're probably going to bump into a PLC, at least one, and could be hundreds of them in your career. So having this ability to talk with them will be very important down the road. So now this is the hard part for me because I have not done one of these implementations yet. So I don't know exactly how we're going to go through it. We're in the early discussion stages on how we're going to make this PackAmell implementation. There are people out there, I'm sure, in this discussion who can help a lot, and so I would encourage you to help because this is going to be useful for pretty much anybody in the ROS-Industrial group. We're going to leverage Sean heavily. We're going to try to keep it into a PackAmell library that's self-contained like Descartes, which will be handy. And implementing the state machine, these are the kind of open-ended questions right now. So how are we going to do this and make sure that it works and it conforms to the ROS standards and everything and that we make it work. Now there's a question over here that P&G PackAmell implementation has a license that's BSD-like. It is like that, yes. But it is certainly easy to leverage it over and over and over again. They just basically wanted to be sure everybody knew that they worked on it. And in fact, that's a lot of the reason why 3M is starting to open up the door. And for this open source community, for us to be allowed to work with an open source community, part of it is exposure. 3M, would like to be more social, so that's a good thing. So we'll probably want to talk about how we get mentioned for this PackAmell implementation. That's just part of the deal. Also, this OPC UA implementation, I really want to. Let's see. Somebody said something about ROS projects and have a compatibility guide with MT Connect. Okay, so we'll talk about that because we're going to need that. A standard OPC implementation would be better in the U.S. because it's such an entrenched standard here, but it's terrible. And having DCOM and working with all of the things that you have to do with it, it's a nightmare. So trying to switch people over here to UA, but it's slow going. Here's some resources I wanted everybody to be able to look at. The PackAmell standard, isa.org. The organizing body is OMAC. Handy things. The state diagram that I'm showing, I think, is in this really nice document, this PDF document that you can download. So we're at the beginning, and we're starting to figure out a way to architect this and make it work for ROS-Industrial so that we can leverage it in our factories. That's where I am. And any questions or concerns?
there's a couple of questions, Lex, about IEC 61131.
Oh, I'm not familiar with that.
I believe that's like a standard for PLC ladder programming languages, so that the syntax is the same.
Right. No, this is not like that. I believe that's more of a internals, like a compiler type of standard rather than a state machine. This really is a state machine with standard tag name interfaces so that you can make modular code that equipment vendors can plug into each other and make work.
And then
with less
maybe just
hard direct wiring.
Yes, yeah. And then just one more question, Heish's question there about it being more, state semantics versus communication.
See here, PackAmell. Not really sure I understand the question. It is a set of standard names, and the standard names operate on states. So it's not a define a name and it can do anything. It's more of a I'm requesting a state change, and then the requested state change goes and is implemented by the various modules.
Yeah, I think we should follow up with Heish. I think I understand what he's getting at, but it'd probably take a while to discuss. So I think we should follow up with Heish, definitely.
Okay, and then ISA 88 actually is the foundation for PackAmell. This is a subset of the ISA 88 standard, and so yes, they're very similar. This is kind of the discrete version of the batch model that ISA 88 was using.
Okay.
Good question. Can we get OMEC directly involved? I think that's a great question for Paul.
The answer is yes, from our standpoint. Maybe Gavin can help us out there. But yeah, okay. So in the interest of time, I'm going to move along. But Lex, I think that was really good. I almost want to say it was life-altering when I found the PackML spec as a PLC programmer, and I know that it may be overstating it, but only slightly. So I'm really excited about this, and I'd encourage anybody to reach out to Lex if you have interest in this or have any thoughts on it.
Yep, I would appreciate that. Thanks, everybody.
All right. Next up is Isaac. Isaac, you ready?
Hello.
There we go. We can hear you. And
okay.
Opening your presentation.
Do you see the presentation now?
Yeah, we do.
Okay.
Are you not seeing it?
Oh, now I see it. Okay. All right. Hello, everyone. My name is Isaac Saito from TORK. Today I'm introducing an industrial CI package, which provides a CI config flow commonly usable for ROS developers. First of all, thank you, Sean, Paul, and Southwest Research Institute for giving me this opportunity and giving this opportunity to develop this package, and also opportunity to talk today. So first of all, I'd like to briefly introduce where I am. I'm at TORK, Tokyo Open Source Robotics Kyokai Association. It's actually based in Tokyo, Japan, and we're providing a consultancy in a non-profit manner since 2013. Our business domains are basically three, and the largest is we're providing the ROS package support for some of the industrial robots. One of them is Kawada Next Stage Open Dual Arm Industrial Robot, and also we provide the support for Denso's VS series. We also we also hold educational workshop and seminars, which we have accumulated for more than 50 occurrences for over the last 3 years. And we also do the custom development for specifically for open source projects. So we're as the team name suggests, we are very driven to the open source robotics. But although we as we develop deal more with the larger established companies, we're getting to learn like the cathedral side of development too. Anyway, so. Sorry, oh, here, yes. So, about the industrial CI, first of all, I'd like to give a quick recap about what CI is. CI stands for continuous integration. If your everyday development work, you make changes to the existing code. For the changes, you have to make sure that the code compiles, runs, and produces the expected outcome. And also sometimes, ideally always, but you write test code to make sure that not only your changes work, but also you don't bring about new issues that didn't exist prior to your changes. And there's more to it. Most likely your code is supposed to run not only on your own development machine, not only on your own development machine, but also you want it to run on other environments, like robots, for example. And then you like to see if it builds and runs there too. All these tasks combined are quite a bit of amount of work, and you have to run these sets of tasks every time you make changes. So, which is quite a big deal for everyday development work. So continuous integration is very useful for this kind of situation. In CI, usually automates software development processes such as build, testing, and also the installation. If you intend to install your software. So whenever making changes, you throw in your changes into the CI system and let CI system handles these tasks, these 3 or 4 tasks, and gives feedback right back you to, and everything can be automated or semi-automated, so that you just have to kick the CI system and just wait for the result. And by introducing CI, you can find the platform incompatibility at the earlier stage, and also you can expect to find the regression, if any. And what's more importantly, you can probably get more confidence and ultimately get peace of mind, because having CI is not itself is not really it's not just a confidence, but knowing that you're not really breaking your system, as long as the CI is working properly, you can expect that you're notified when your changes break your code. So knowing this will actually gives you just a peace of mind. So I think it's a really good idea. So CI is implemented as a software, and a lot of them are actually available online as a services on the web. So and I've listed 4 of them here as an example, but there are quite a few number of the available CI services. And on the one on the left, Travis CI, which is, I believe, based in Berlin, Germany. As far as I've seen so far, this one is the most used in the ROS community. And the ROS maintainer team at Open Source Robotics Foundation actually provides quite a good amount of feature for specifically for ROS developers. Well, I have to admit that before I started working on this industrial CI project, I should have gone into I should have looked into more detail of what ROS.org provides in terms of the continuous integration, so that I can integrate their services better. But this is still I think this is a good list of the future work for the industrial CI to live to work better with the ROS.org services. And one of the last, the BuildBot ROS, this is also specific for ROS development. And if I understand correctly, this is more like a software, standalone software that needs to be installed on the CI server. So I think you have to set up your CI server first, and then install this BuildBot ROS. So it works better, more like with the private company product situation. In fact, it has been already used by the commercial companies, and the original developers. I believe Michael Ferguson, he's now currently a CTO at Fetch Robotics. He is the original developer. So, yeah. So there are quite a few options for a CI service. So with these options available, what is the issue for robotics engineers not who might not have introduced yet the CI service? So configuration of CI jobs takes quite some experience. So CI platform like Travis CI, for example, it takes. Well, it's actually not that difficult to learn. You have to know some kind of grammar, but it's a fairly simple shell script. But still, you have to learn in shell script, and you have to learn the specific grammar of Travis CI, and this. I said simple, but still, you have to do some extra work in addition to your normal robotics jobs. So, yeah, and then also in order to configure the CI jobs, you have to know at least some level of software development, a software building process, like build and install, and then what kind of tests do you want to, and yeah, those stuff. So all these are just probably additional tasks for most of the robotics engineers. So end up with so it's totally understandable that the robotics engineers tend to push this away for the future work, and then end up with CI configuration not updated for a while, or not even introduced yet with your repository. Today, this year, 2016, I've seen quite a few of repositories, ROS repositories that contain the ROS packages that are mainly that are significantly used, and then there are now no CI configuration available on the repository. And whenever I found that kind of repository, I just opened the pull request, utilize industrial CI package to set up the CI configuration, and so. If you're one of the maintainers of those repository, I apologize if I bug you too much, but hopefully you love it in the end. So I already mentioned industrial CI package a number of times, but so this is a link to the GitHub repository. So what it does again is provides a CI configs for CI configs that can be commonly used for ROS packages. And well, actually, I didn't think of this idea to utilize the common configuration from many different ROS repositories. It was originally I found this idea originally at the so-called JSK Travis repository, which is made and maintained by JSK Robotics Lab at the University of Tokyo. And so currently, industrial CI is used by mainly uses Travis CI as a CI server. Although it can be easily, although other CI services can be easily integrated. So yeah, and currently. ROS distribution D3 are supported. Indigo, Jade, Kinetic, all are supported, and only Kinetic runs on the Docker image. A Docker image that runs on top of the Travis CI, because we did this only because the Travis CI, as far as I know, does not yet support the Ubuntu operating system that Kinetics runs on. So anyway, so if you're maintaining the package that run on Indigo or Jade, or even if you're maintaining a package that run on Indigo or Jade, you're welcome to use this package. And also, if you're wondering or curious if your package runs on Kinetic, but still not plan to actually make a release into Kinetic, you can just add this Kinetic option to the industrial CI configuration. So, advantage of using industrial CI, I can think of a few of them. So, on contrary to the, for example, the ROS.org services, it utilizes mainly, as I said, utilize the Travis CI, which is basically a commercial service. And then we're currently utilizing the open source version of a commercial service, by which I mean is the service is updated and maintained very, very, very well. So we can probably take advantage of the up-to-date service. And because this is a community project and still at the very early stage, I should say, it's very flexible. So you can give whatever the request or opinions in order to make this package suit your own need. So please give us feedback. And also it can be used by the private repository. So if you're maintaining the private repository in your corporate production purpose or whatever, you can just use this. And I know some private projects are utilizing this package already. So workflow, it's quite simple. So at the top, you write your own code, make changes, and open the pull request to the source repository. And source repository has to be configured for CI service. in order to configure your source repository for CI service, you have to do two things. One, hook up your source repository to the CI server, and also add the CI configuration file on the source repository, which for Travis CI is called a .travis.yaml file. That's it, and then you're ready to use the CI service. So at the top of the diagram, you make changes and open the pull request, and then the pull request triggers the CI job. And actually, this is missing from this diagram, that the once the pull request is made, the source repository gives a signal to the CI server, and CI server tries to retrieve the industrial CI package from the industrial CI repository. That's it. That is what is missing from the diagram. But so it's based on the pull request. That's the idea of it. Oh, 2 minutes. Okay. So this is an example of the configuration on the source repository. This is actually all. This is the entire file of the configuration as an example. And I don't go into the detail, but I hope you get that the config is pretty simple. In this example, we are testing a ROS distro of Indigo and Jade, and do some type of combination. And we also utilize the so-called pre-release testing that ROS.org provides. Yeah, so and then pretty much all, not all, but so many repositories just use exactly the same configuration as this. So this config is pretty versatile. And I don't exactly know how to get the number of the repository that are using the industrial CI package, but I get this image from the Travis webpage, and go into the summary at the bottom. A daily average of the this is the summation of the Git clones. And Git clones, I mean, the industrial CI the source of industrial CIs is obtained by git clone command. And this is a sum of the git clone of the daily number of the git clones. And then average is, I don't really understand the difference between the clones and unique clones, but let's use just the less number, 59. So I think it's fair to say that the 59 times per day it's used, which means somebody runs the CI jobs 59 times by using the industrial CI package. So future work, there are some improvements that are already requested. Most notably, the Travis CI limits the capacity of the log up to 4 megabytes, so that everything that excess the amount, the job will be terminated. So that is significant for the packages that are larger. So that is that's on the to-do list. And as I said previously, ROS.org provides very good services in terms of the continuous integration. So I just like to delegate whatever the features that are overlapping to the ROS.org, and we probably like to focus more on the feature that they don't provide. And so because the package named as industrial, this Oh, so this package works for non-industrial packages as well. This is currently, I don't think I introduced anything that specific to industrial context, but because of the package is under the ROS-Industrial organization, it would be great if we can introduce some kind of some kind of the characteristic about the software maturity or something like that. I haven't thought much about it, so we will appreciate if you can give us any input about that. So there are some related resources online. And lastly, I like to thank all the users who give us some feedback and pull requests, and particularly Matthias Lutke and Heisch van der Horn. Hope I pronounced their names correctly. For their contribution, for their continuous contribution from the very beginning of the project, and also, of course, the Southwest Research for giving it this opportunity again. All right, that's it. So, do I have a time to take questions?
Yeah, one question while I switch over, and I just want to say, Isaac, yeah, I think you're one of the best maintainers. You're really responsive, and you continue adding features. I think you do an excellent job.
That is not a question, so just thank you. Sorry, I took too much time, I guess.
That's okay. Next up is Mitch. Mitch, you good?
I think so. I just unmuted. Can you hear me?
I can hear you. We're a little bit tight on time, so if
I will note it. I will see if I can get us caught up a little bit, despite that scary number when it comes to the number of slides. So just a quick kind of introduction to who I am, Mitch Pryor, and that UTNRG is actually stands for the University of Texas at Austin, the Nuclear Robotics Group. And just as a quick bit of background, we started in 2008 and were kind of created out of a frustration at Los Alamos National Labs that a group that certainly would want to have advanced automation capabilities to reduce the dosage for their operators was having trouble transitioning technologies from academia or even industry and get them in to kind of meet their requirements. So we formed the Nuclear Robotics Group. Our graduate students take about a third of their courses in nuclear and 2/3 in sort of robotics, automation, traditional mechanical, CS kind of robotics topics. And that really kind of helped break the dam because it allowed us to understand the requirements of the domain that we were going into. And as you can see there that, primary deliverable here is actually getting students to take jobs at Los Alamos, which meant that they had people on their end that would be able to receive the technology and help get it in place in a rather complicated environment. Since 2008, when we started, we've graduated 7 students, 5 of which have taken jobs at Los Alamos. We have thrown at least 4 robots kind of over the fence, so to speak, to get them at least running in their cold labs, and at least 1 robot's kind of been deployed in a hot facility. So we're starting to see some real success there in terms of reducing the dosage of that would be taken on by their operators, and they can start to do things more efficiently. And so why does ROS or ROS-Industrial come into play here? It's really about the maturity that ROS-Industrial kind of helps us speak to when we're starting to use ROS. It helps build confidence in our sponsors as we see it. And ROS has become critical because if all of a sudden I take what was normally a robotics student spending their entire time doing robotics and I have them spend a third of their time in nuclear courses, then we just don't have the time to reinvent every wheel like that was too common. Sometimes I get so that our students don't get to deep dive in some of the robotics topics I used to, but because of ROS and ROS-Industrial, they simply don't have to. So confidence for the sponsors, simplifying the technology transfer, and really reducing the learning curve for these students who take a a very challenging and yet shorter degree program, because most students spend the last 2 years of their PhD as kind of all but dissertation full-time affiliates at Los Alamos. There are some disadvantages, though. One, so many questions. All the ones that we hear is open source secure, is open source reliable, will this be supported in 20 years, et cetera, et cetera. ROS-Industrial does a great job of helping us to address that. And the reason I'm here on the second one is because it is easier to be a user, but now we're starting to really develop some things to solve some pretty challenging problems. And how do we contribute it back in? And I am very happy to say at this point that Los Alamos has recognized that our students have done a good job of sort of abstracting out the core robotic requirements from the applications that happen at Los Alamos, which was necessary, and therefore sees that they're a national lab and that helping us get our code out into the world is a general good. So huge kudos to Los Alamos for seeing that. The reason we haven't been able to release it quite yet is, of course, everything goes back to Washington, D.C. for this kind of thing. Yep, they actually probably are more open than 3M at this point. I've been told that getting some of the approvals out of D.C. should be a formality. My fingers are crossed, but I am optimistic that what I'll show you today will be packages that we can start to develop and with Sean in the very near future, some of which is actually already out there. Just a quick idea of some of the things that we do for them. A lot of it is about, using industrial robots to do kind of advanced capabilities. We've put robots into neutron beam ports to do neutron radiography, non-destructive testing, similar to X-rays, but on metal objects. Robots require us to be extremely precise. We were able to test that and get that precision capability using ROS that we weren't even able to get to with the Yaskawa drivers. And robots with the complex motion programming that is available to us allowed us to take pictures of objects that are larger than the beam port they are going into. That's been a huge plus for us in terms of really simplifying their process. So that's one we threw over the fence. A second one was a mobile system. Again, if you go to our website, I'll show that on the last slide, you can actually see videos of all this stuff. Our mobile robots are able to go in, do routine contamination testing. They're able to do inventory and inspection, cross-reference what they see with the cameras with the barcodes to databases. A lot of the inventory inspection is actually some of the more dosage expensive applications they have at Los Alamos. In terms of the operators, the ability to have robots go in and just say that everything is still where it was supposed to be and nothing's on the floor and nothing is hot or leaking is a huge boon to them. And we've been able to utilize a lot of ROS, NavStack, and Vision, and adapt robot capabilities for that. We did some work that actually led to some stuff here, which was to actually do material reduction. They have a lot of pieces they need to size reduce. This is very hazardous and can have some dosage, some dust, that kind of thing, definitely things you want people to keep out of. It also has a lot of contact requirements associated with uncertainty, many small batch jobs, many different geometries. When you start size reducing anything, of course, it's not like putting them together. You can warp things. It adds uncertainty to the system, and there's quite a bit of peripheral integration. So we had to integrate a lot of the vacuum systems with ROS and even that hole punch that you see there in that picture. ROS was able to help us do a good portion of it. ROS-Industrial drivers allow us to get it running on the mobile manipulator, and we were able to add a few things that I'll talk to in a bit. These are just a few of the things that we've been able to throw over the fence that kind of gives you an idea of kind of what our industrial capability works. Yeah, unfortunately, that link is not actually a link. I think that I got lost on the PDF. If you go to our website, robotics.me.utexas.edu, you might be able to parallel process some of the videos that you see there. So what does that mean if we actually get a lot of this stuff out in terms of that release update? We have quite a few packages that will be available, and I'll turn some of these into 10-second slides to help get us back on time, and some of these I'll talk about in a little bit more depth. But we've got some control packages that will hopefully work. We've had to integrate some hardware that we found some things lacking a little bit in either ROS or just not existing. Cartesian jogging and teleoperation is something that still exists in Los Alamos that doesn't in a lot of industries, so we had to work on that. And I'll spend a little bit more time talking about the upcoming object recognition packages, generalized contact control frameworks, and some teleoperation based on virtual networks. So first, one of our students, Andy Zelenak, did a lot of contact task work, wanted to evaluate both linear and nonlinear control packages. Definitely wanted to be able to use the ROS drivers to run the robots to kind of see what happened and get us out of the standard MATLAB kind of stuff. So some of the stuff that's actually been used at Los Alamos for contact tasks is actually released both as a part of ROS, and I think there has been some use already out there. So you can follow those if that's something you would be interested in pursuing a little bit about. We developed the Robotique. We use a lot of the three-fingered grippers. We like the Robotiques because the mechanical linkages of the fingers and stuff are much more robust than a lot of the more organic materials you might see. The issues sometimes with these sort of coupled fingers is that the collision models are hard to calculate because the fingers tend to wrap around and kind of figure out exactly where it is difficult to integrate with the collision model. Furthermore, a lot of these times you wanted to use them in teleoperation and you needed a simple sort of user interface to kind of make that happen. So we developed the GUI there, we developed the collision model, came up with a way to kind of do the forward kinematics with the 7 degrees of freedom there in it, and publish these joy states, which allows us to do collision detection with them. So that's been a bit of a boon for us, that one. The dual arm system for the SDA5, we were able to update the SDA10 work that Yaskawa had already put out there and create full packages for dual arm coordination of that system. Thank Yaskawa for lending this robot to us. We did all this for the Amazon Picking Challenge, and that's why we can already make this available to people who are interested in. This thing will be recorded. Oh, there we go. I'm going to ignore the questions so I can help keep us on time for the moment. I'll come back to them at the end. One of our mobile systems uses 2 Universal Robotics 5 robots mounted in a dual-arm format on top of a Husky robot. ClearPath did the integration for us, and they did a really good job of kind of setting up the packages to start. But we were able to unify the robot model to get them all to work, to allow us using the MoveIt interactive markers to move the robot and the arms all simultaneously as necessary, and to improve what is necessary when you're doing mobile platforms when they have arms in them, which is a lot of skid steer systems tend to assume a constant center of mass, which becomes not true when you have arms, particularly arms that may be lifting heavy items. And our empirical research showed it did have a fairly significant impact on the navigation capabilities. And so we are currently validating our control patterns for dual arm systems on mobile systems to kind of get them out there. Cartesian jogging. We had submitted this to ROS-Industrial. I understand that there have been some recent updates by some third-party sources, so we're very excited about that. So if there is a need for some either LabVIEW integration or Cartesian teleoperation of your industrial robots, you might take a look at this package. The ones that I'm most excited about are the ones that Lionel really kind of sponsored recently. We did a lot of various applications with vision work, and our most recent student working on vision recognized that there are so many good vision things, there was just no way to really kind of integrate them when you needed different combinations of them to work in different situations. So, for example, barcode reading, 2D classifiers, 3D point cloud object recognition were all needed in different combinations and different applications. So the object recognition package uses common filtering, servers, and common data collection, and then you select which object recognition algorithms you want to use, which their answers are then fed into a core, which gives you the results of their combined analysis, which can then be used in applications. So it allows us to set up the vision systems for a wide range of applications in a short amount of time. There is a sorting video on our website that kind of shows that in use for a robot inside a glove box. Generalized contact control force is one that allows you to integrate very quickly and in real time, even dynamically, the contact control capabilities of a robot and its multiple axes. Now, our videos, I can't remember if they're on my students' YouTube channel or ours yet. I will get them on ours shortly if they're not there. For the different axes, we can do this in real time. We have the robot moving around, and we can change the control law for each different Cartesian axis and orientation in real time to make it compliant in certain situations, stiff in others, and or follow paths in another. This allows you not only to set up these nice little GUIs that make little fun academic applications, but also very rapidly set up applications with multiple contact modalities throughout a given task. So variable normal surface fixtures, often we need to inspect things. Teleoperation around things like circular objects can be kind of a pain with Cartesian jogging, but if you set up virtual fixtures and coordinate frames and create a very simple set of control buttons to move from one to another, you can quickly and easily inspect things at whatever fidelity is necessary without ever running into them. And so that was something we set up, and the ability to automatically generate these normal fixtures is something that we are hoping to release. So that's us. I can certainly not take credit for all of that. That's why I put a picture of all of my students as well as some of our sponsors in there. You can picture me. I'm the one in the red shirt with the hand on the robot. There's my contact information and the website if you need it, and that was 14 minutes by my count, Sean.
That's awesome, Mitch. Thank you for that. And there's a lot of capabilities there. As you start releasing these things, please let us know so we can promote the good work that you're doing. If anybody has any questions, feel free to ask. Looks like somebody's asking for a link for the object recognition.
So the object recognition package is one of the three things that Lionel has agreed to approve, but we are still waiting for approval from the NNSA in Washington, D.C. I've been told, fingers crossed, that's a formality, and we will make sure that ROS-Industrial is able to announce when it, as well as the GCCF packages, are available, hopefully this summer.
Awesome. Well, thanks again, Mitch, for the presentation and all the good work that you're doing. And we'll move on to Dave Coleman. Dave, you there?
Hi.
Okay, we can hear you, Dave.
Great. I know we're running pretty late here, so I'll try to make this speedy. So multi-arm control and MoveIt was what I was asked to talk about today, and I have worked on this in the past and am currently working on it. So I wanted to just clear up what it currently has, what we need to add for capabilities, and some different approaches used. So when I was given this title, and this is kind of the scope that I presumed we were curious and interested in doing and accomplishing in MoveIt. So we want smooth trajectories that work for multiple kinematic chains. And so a kinematic chain, think of it as basically your shoulder joint to your end effector. That's like a classic one, but it can also include your legs if you have a humanoid robot, or even something that goes to your neck, your pan tilt of your head or something. And we want to do this quick. And so another bullet point here is alternating closed loop kinematic chains. When you have your two arms holding something like a tray, you suddenly have a closed loop chain, and those are much more difficult to solve because they lie on a very thin solution manifold. Typically, we solve those by solving one arm and then the other one, or like randomly sampling it, and then you solve the other one using inverse kinematics so that it matches up. Another example is two legs. When they're both flat on the ground or even touching the ground, you kind of have a closed loop chain there. And then another objective is that sometimes you have these joints that are used in multiple chains. So in humanoid robots, or even in some industrial robots, you have a torso that can bend or rotate, and those will affect both of your left and right arm if you have a two-arm robot. So how do we use an IK solver that can accommodate those changes? And lastly, and this is more advanced, is I'm going to touch on manipulating objects being held in one arm and doing something with the other arm. So currently in MoveIt, we have the ability to solve for multiple arms out of the box. and that's great news. Johan added that early on, but what it does is simply it has two IK solvers, maybe just the KDL that comes by default or IK fast, and it just has a loop for every chain. So it'll go through each arm and solve it, and then make sure that the two arms that it's solved for aren't in collision, and if they are, it just retries with a random seed. So it's just iteratively attempting. And it does not have the capability for this torso rotation or torso lift. So like the PR2, you can lift its whole torso up, and you could consider that part of an arm. But if you're playing for two arms, you can't currently in MoveIt. So that's a limitation. And the Motoman that was pictured in the first slide is pretty popular. It has a torso rotation. So I'll address that now. One solution, I'm not like the most expert person on inverse kinematics. There's a lot out there, but I have done some work on it. When I was at JSK, Kei Okada and some of his colleagues were helping me in solving IK for humanoids. They're really good at those things. And one of their solutions is you create, it's pretty classic, but you create a large Jacobian, and you're tracking not just one Cartesian pose of the end effector tip, but you have multiple. So you have a very large Jacobian, and some of those are overlapping joints when they affect two different end effector poses. And so I made an experimental version of this called MoveIt Whole Body IK Solver. Never finished it, unfortunately, but it does have, it can do the basic solving. The main thing it's missing is the ability to fix your feet to the ground. So right now the feet are just kind of floating. That needed to be added still. And while I was working on this, I did make a large number of pull requests to MoveIt so that we could have all of the kinematic base API specify different poses at once in a kinematic call. So just making a lot of vectors instead of a single pose. And something that I've heard from a number of people as a potential solution to an IK solver that's in MoveIt that can solve these multiple arms is perhaps stack of tasks. They have really pretty good documentation. It appears they've been around for a long time. They've done a lot of impressive humanoid multi-arm manipulation tasks, but it also has some other features in there that are overlapping with MoveIt. It's kind of a different mindset of how to do motion planning than what MoveIt does. It's not sampling based, as far as I understand. But the takeaway from this slide is that it would be great if we had a IK solver that by default, like through the setup assistant, could solve two arms at once. And right now we don't have that. We only have separate ones that can kind of solve two arms at once. And so the second topic of my quick presentation I'm trying to give is motion planning. As you guys know, MoveIt mostly does motion planning through sampling-based things, OMPL. And for the OMPL interface, there are two spaces that it plans in, either joint space or workspace. Workspace you can also consider Cartesian space, or like the tooltip of your end effector. And both these methods can do dual arm planning. So for the first one, you just randomly sample both arms and hope that they don't collide. And just like regular RRT or PRM, it's just all random sample, and you can just get two arm free space planning, but it creates pretty crazy motions. What it can't do is constraints like not tipping a glass over or having two arms attached to the same object. 1 second. Because the chances of you sampling randomly that small constraint is like computationally intractable. So to get around that, the second thing that was built into MoveIt by Johan is sampling the pose of the object you're dealing with. So that would be the pose of a tray or a box or a cup you're holding, and then using IK to solve out the closed kinematic chain of the two arms. This is slower because it requires at least one IK call, but it does allow you to, when you sample a pose of your object, determine if it's too far tilting in one direction or if it's upside down, and you can reject these samples as you go along. And so that's a feature we already have. I think it's hard to use the second one currently because there aren't a lot of good GUIs for it. It's more in the experimental state. So if you're just using the RViz interface, or even I think the Python interfaces, it's going to be hard to find the right ability to set it up in the code to ask it to do these things, from my experience. Obviously, if you go into C++, it's all there, or if you do some custom code. Something that we have pretty poor support for is computing Cartesian paths that go along a particular set of waypoints. So it does have this. It's compute Cartesian path in the robot state class, but it fails pretty often because it doesn't have any functionality to retry or to resample when it gets stuck in a local minima. So if you're moving along and your arm reaches a joint limit, it doesn't know how to back up and try a different way of doing it. There's no weighting system. It's really just iteratively calling an IK solver and hoping that it doesn't get stuck. And it also can't account for things like having the z-axis of your interfactor free. So if you don't care about the rotational part of your grip, or variable tolerances and roll pitch yaw, which is what you guys are probably presuming I'm hinting at Descartes right now, or sorry, Descartes' pronunciation. That's a better solution to this that ROS-Industrial has been working on. So this is a big area that needs better support in MoveIt. And so it's actually a project that Sean and Paul have been working on behalf of SWIRI and NIST and ROS-Industrial, is doing Cartesian paths with dual arms. And it becomes a pretty big configuration space problem. But yeah, I'm sure you guys know this, but it's for undefined. Descartes is for undefined Cartesian trajectories. And so we have your current state where you are, and we want to plan through free space to the beginning of your Cartesian path. So for example, we might be holding a marker and we move it against a whiteboard that we want to draw on next whiteboard right now. And then from there, we execute a Cartesian path. Let's say you're drawing a shape or some letters. And then when you remove the marker from the whiteboard, you want to have a free space path to where you want to place the marker. Maybe you're releasing it from your hand. That's just an example. These could be deburring operations, what have you. And the approach that I'm taking right now is to combine this roadmap of free space movement, which is the box on the left bottom of the slide, and then connect it to the way Descartes currently plans trajectories of discretizing the space between a series of points, where each point is a number of samples based on tolerance, collision, and kinematics. And then we, from there, connect back onto an exact copy of that same roadmap to place something down the free space plane. And it's a little bit off topic from the multiple arm points, but I wanted to point out, this is a new graphic I made yesterday, that you have to be smart in the way you connect the free space to the Descartes graph, because as you see here, the orange path on the left, if you choose the wrong state to attach to, or the wrong node, you won't be able to attach to the red path in the middle, and you'll miss the second orange path. So we have to be careful, otherwise you could free space plan into a configuration that doesn't work for your Cartesian path you need to take, because you can get, again, stuck in local minima or joint limits or such. And so this is a form of hybrid planning where we have a discrete state as well as our joint states that we're planning in. And so the discrete state tells us which of these three levels or tasks we're on, the free space, the Descartes, or the free space task. And so we're working on making this work in the high dimensional space of dual arms, but it's a little tricky because of the dimensionality. So I'm looking at fancy caching or experience planning right now. And then a really higher level task that we're not quite on yet, but I think is of particular interest to a lot of applications, is the ability to pick up an object in one hand and then work on it in the second hand, but having both moving at the same time. And so you're solving for, it's a much bigger workspace because you can rotate with both arms, but how do you plan for that? It's pretty difficult. I think the approach that I would take initially on working on this would be to treat the workpiece you're working on as the base frame, as your world frame. So considering it like not moving, and then you can really just consider both the arms as one large indefector that happen to be attached by the earth, by the surface. And so then you go from, if you have two 6-DOF arms, suddenly you have like one 12-DOF arm, and you can get to a lot more places on it. And then we'll have to have a lot of mode switching and MoveIt on how to switch between a single arm picking up the object and then becoming a much higher degree of freedom arm. In this case, welding in the picture we see here. So that's definitely something MoveIt doesn't have yet. the base implementations are there. MoveIt has like, the hooks for it in the source, but there's still plenty of work done to make this sort of application working. And so my final thoughts, keeping this going fast, is currently when you're playing with two arms in MoveIt, even let's say with the RViz plugin, you'll find that the paths are pretty long and unsmooth. And I believe that's because it's just such a huge configuration space that oftentimes it will find a path eventually. It might take a minute, but even when it finds that path, it didn't find the best one because we're randomly sampling. And so we need better ways of finding the different homotopy classes through the space so that when we do run smoothers on it, it isn't stuck in some strange collision orientation where it can't find a way through, or some joint limit. Another thing MoveIt needs, like I mentioned earlier, is the GUIs for doing motion planning or with two arms is kind of lacking, I think. So you can have two interactive markers in the RViz interface, and so that's nice, but there aren't GUIs existing for telling it not to like turn over a tray or how to like keep the arms equal distance to each other while you're moving a tray around or some box you're picking up. So it's something we need to add for sure. And I think that's it there. We need some examples of like applications of using two arms. I see some comments on the side about TrackIK possibly having two arm support. I did not know about that. That's great to hear. On a side note, I would love to see TrackIK better integrated into, say, like the setup assistant and overall into MoveIt so that more users can use it quickly out of the box with MoveIt. And because I read into it, it does look a better approach.
Awesome. Thanks, Dave. And I want to see TrackIK integrated too. It just needs to be released as a Debian. Intent, Patrick. Do you want to answer a couple of questions? It looks like there's a few.
Yeah, I'm happy to answer questions. I'm looking at this chat box. I'm not sure what questions there are.
I don't know if John was referring to your project or just in general. He says in general. So I can see a lot of uses for this, Dave. I think there's, the welding example is a really good one, but there's certainly many more. I'm looking forward to, coming to conclusion on this project and seeing what results you're going to be able to present. Any other questions for Dave?
I see a lot of machine learning questions going on.
Yeah. Sorry, RD, for coughing into it. Patrick, if you want to ask a question, you gotta type it in to the chat window.
All right.
Okay. Well, I want to thank you, Dave, for your time and all the speakers. You guys did an excellent job. And there's Dave's contact info. I would encourage everyone to reach out to the speakers. We're happy to answer and field questions. Thank you, everybody, for kind of staying on the line. I know we ran a little bit long. My apologies for that. And but I have nothing else to present. I did all my material up front. So that's it. If people have some general questions, I'm happy to stick around as our others, I assume, to answer them. But thank you very much for attending the meeting today. I appreciate it. We will post a video, James, of this, and if the presenters allow, we'll post links to their proposals as well, or their presentations as well. Well, it looks like the mass exodus has begun. But thanks, everyone. Thank you for your time. I will see everybody around. Thanks. RD, there isn't a LinkedIn users group for ROS-Industrial that I'm aware of. I've never created one, so I'm not sure what it would take. I'm sure we could start one. There might be one for ROS in general, so that's something we could do. RD, if you create one, I don't know if you can or somebody else has to do it, but if you put one together, we certainly promote it to the membership. All right, thanks everyone.